No intro, no outro, no middle intro. Let's get right into it. Now, this is part 2 of the Minecraft from Gdevelop tutorial. Now, if you have not seen part 1 of the Minecraft from Gdevelop tutorial, I'll have a card up in the top right corner of the screen to part 1, and you should watch that first because that's what we're going to be continuing off of. Now, if you've already watched part 1, that's great. And we're going to, in this part 2, we're going to make collision and not the same as this collision. 'Cause I know everything might seem like it's fine right now, but this collision right here is not flexible because if I were to jump, you can't tell right now, but if I were to jump, I would still collide with air because, like I said, once again, since there's a 2D editor, it can't actually. We have to make sure the engine can tell when we're actually high up and when we're not high up. So in this tutorial, we're going to be making jumping, falling, and upwards building as well as actual flexible collision. So let's get right into it. So we're going to be doing a lot of coding. We're not going to be doing as much testing because we have a lot of code to do, and not too much, not as much as last time. But the first thing we want to do is make our fall code. We have to make our fall code. And in order for us to make our fall code, we need to first start by making an object variable on our camera object. So let's double click into our camera object, go into variables, and we have these variables here. We're going to click add a variable, and we're going to call this variable jump. And the reason why I'm calling it jump because not only will this variable be being used to calculate how fast we should fall, but this variable will also be used to calculate how we should jump because the falling and the jumping, they are very like similar. They're not interchangeable, but they're connected. That's what I'm trying to say. And the jump variable is going to be a number that starts off at 0. It doesn't really matter what it starts off as because we're going to be changing it anyway. And now let's go into our scene editor. And now let's create a new event. And I'm going to right click this empty condition. I'm going to right click it and put move events into a group because we're trying to organize our code at least a little bit. And I'm going to call this group falling. We're going to call it falling. Now, falling is something we want to always be happening. And as well as when we're on the ground, we're going to have ways to check whether we're on the ground so it can stop. But falling is something that's always going to be happening. So we're going to make sure that we won't just fall through the ground all the time. But falling is always going to be happening. So no condition here. We're not going to add condition here. Now, we're going to add an action. And the first thing we want to do is change the variable of jump. Change the variable of jump. So I'm going to go into camera. I'm going to scroll down until I find object variables. And here it says change the number variable. And I'm going to click jump. And we don't want to set this equal to something. Since we're following, we want to subtract the value that we're going to set here. So we want to subtract, and the number I'm going to set here is 6. You can set this to whatever you like, but to me this is a good fall speed. And 6 times time delta. 6 times time delta. And basically it will like almost increase, not increase over time. We will fall based on the frame rate of the game. So even if the game is running at 30 FPS, it will still be moving the same as if the game was running at 60 or 120 or 144, things like that. Time delta makes sure that our physics of the game are consistent no matter what frame rate we're using. So I'm going to click OK. And now, how are we going to actually change the Z position of the camera? And the order we do that is we change the Z position of the camera by going into our camera. And I'm going to type Z. And we don't want to do Z order, we want to do Z, the elevation. And I'm going to set the Z position of camera. We want to add, we don't want to say equal to, we want to add the camera dot variable. And we're trying to access the camera variable jump. So I'm going to put camera dot variable. This shows that this is the object variable. Camera dot variable. And then I'm going to type in jump. And if I run the game right now, you'll see we'll just keep falling. We'll just keep falling. And let me just preview it here. We're going to keep falling. And that's because we haven't set any limits yet. And that's because we have to now set plane collision. And what do I mean by that? You see this ground that we're standing on right now? This ground, I have to set this as a plane. And same thing for the blocks. And I know you might be thinking, why would the block be a plane? Well, the block is a plane because it's going to be simpler for us to program it later. We have a way of detecting when we're touching the body of the block and when we're touching the top of it. So they're both going to be planes. Now, in order for them to both be planes, let's add an object group so that our plane behaviors that we're about to program, they will apply for all the objects that we put in a specific group. Now to open the groups panel, you go to the top right corner here and you go to where it shows the 3 blocks and it says open objects group panel. And let's add a new group. And this group is going to be called plane. It's going to be called plane. I'm going to call it planes just so simpler. And now we want to double click into planes. And we're going to add 2 objects to this group. Now the first object is dirt because that's what we're standing on. And the second object we're going to add to the group is the stone. And I'm going to hit apply. And let's go back to this events editor. Now back here, we're actually going to delete where it says separate separate the object from stone, separate camera from stone. We're going to remove this because, like I said, this code is not flexible. I was just using it for the first tutorial just to show some collisions, but we don't actually need to use this here, so I'm going to delete this. And let's scroll back that down. Now the next thing we need to do is set our plane code. Now we have to make calculations for our plane code, basically being able to detect where the player is, whether it's on top of it based on Z order. And it's going to be slightly complicated, nothing like rocket science or anything, but it's just going to be a little bit complicated. So please follow along with me here and pay close attention. Now, the first thing we want to do is add a new event. And I'm going to once again right click this event and move it into a new group. And I'm going to call this group, I'm basically going to open a snipping tool. I'm going to call this group plane collision. And we're going to open up this group in the drop down menu. Now the first thing we want to do is add something. Now I'm going to click here. Make sure you click on this condition right here so we can add it there. I'm going to click this plus sign right here in the top right and add a new event. Now the event we want to do is repeat for each object. Repeat for each object. And the object where we want to be repeated for, we don't want it to be repeated for any of these specific objects. We want it to be repeated for all of the objects in this object group, which is called planes. Now every single object, the dirt and the stone, all of what we're about to program will apply for those 2 objects. Now the first thing we want to do is put if camera, going to click camera, and I'm going to type collision. If camera is in collision with planes, which is our plane group here. And we're going to just set this as default and click OK. Now we want a sub event because we're trying to check first if we're even in collision with planes, and then we want to check a certain thing of whether or not we need to stop on top of that plane. Now I'm going to right click and put add a new sub event here. And you got to be careful with these sub events because if you don't make it a sub event, the code will not work the same. And I should explain sub-events in a later tutorial, but sub-events are an event that only runs when another event is true. That's the simplest way I can explain it here. Now, let's go and add a condition. Now, the first thing we want to do is check if the camera's Z position, not the camera's Z position, if the variable of jump is less than 0. Because the variable of jump is less than 0, that means we know that we're falling. So I'm going to put camera. I'm going to scroll down to where it has number variable. And I'm going to put jump. I'm going to put if it's less than 0. Because this signifies that, okay, the player is falling now because this number is less than 0. And now we have to do a certain thing now. Because we have to pretend almost. We have to visualize invisible feet on our 2D player. We have to visualize this. And how do we do this? Basically, we have to set an offset based on the Z order of the camera. And I know this sounds complicated, but basically we're trying to check if a certain offset is within a certain range of values so we can know whether we need to stop on the plane or not. Because if we set it at the regular Z position of the player, it'll be quite high and it won't collide the way we want it to collide, the way we think it should collide. I'm just going to show you this in a coding form. Now, I'm going to add a new condition. I'm going to go to other conditions. I'm going to go to events and control flow and then compare 2 numbers. We're comparing 2 numbers. Now I want to put in this first parameter, in this first expression, if camera dot z plus 8. Now I'm going, if you can visualize it, camera dot z plus 8, okay, you get the z order, not the z order, is basically the same thing, but you get the elevation, the height of this 3D player, and you add 8 to it, which means this is lower than the player because in Gdevelop when you add a number into the y position, not to the y position. In this case, it will be higher because z is different from y. So in this case, it will be higher. So we're trying to check if camera.z, something slightly above the player, is less than, not less than, greater than, I'm going to put greater than. If it's greater than camera, not camera, plane group, the planes that we have, if it's greater than planes dot z. So basically we're saying if camera plus 8, which is camera dot z, which is slightly higher than the z position of the camera, if it's greater than the z position of our plane, then we want to do a certain thing, which is basically what we're going to be doing is stopping on top of the plane. But not only do we need this, we need another condition because if it's only this condition right here, if it's plus 8, that means if we're high up in the air, we're just automatically going to be stopping on some type of plane. So we have to set a downwards limit as well. So the downwards limit is going to be quite simple. So I'm going to copy and paste this actually. Copy this and paste it. And I'm going to double click into this most recent one. And I'm going to put camera.z minus 150. And why am I putting minus 150? Well, I'm going to click OK for a second. We're going to go back here later. Minus 150, as you can see, our player, I'm going to go to the instance editor. You can open it right here. And I'm going to click into camera. As you can see, our Z right here is 150. So I'm trying to set the lower limit as 150. We're trying to keep it consistent. Now, it doesn't have to be this. If you're programming your own Minecraft, it doesn't have to be minus 150. It can be whatever your starting Z position was, but make sure you keep it consistent throughout the code. So, we're going to double click into this, and we don't want to put if it's greater than, we want to put if it's less than. We want to put if it's less than planes.z. We want to put if it's less than that. So basically, if the lower part of our camera is less than the planes z order or z position. Now that we have these events set up, now we want to now we want to see whether or not we want to make it stop. And we're not going to really see, we're going to make it stop. Now, we're going to click the camera, I'm going to type in Z. I'm going to type Z and go to Z where it says elevation. And now we want to set the Z position of our camera. Now, this Z position is going to be equal to planes, which is our group, dot Z. So now we're setting it to the planes dot Z plus 150. Plus 150. Now, I won't be able to run this and tell what's really happening. Well, actually, I can run this and tell what's happening. We're gonna see it right here. And now I'm actually standing on the plane. As you can see, I'm standing on the plane, so I'm not falling through it. My fall code is still active, but because we programmed this plane collision, now I'm actually standing on the plane. And it's not any jittering or anything. I'm actually just standing on the plane. And a simple way to explain this, if our camera is within a certain Z range, that's basically what we're doing. If it's within a certain Z range, you can set this however you like, but these values work well because our player is 32 by 32. If it's within a certain range, we want to set the Z position to planes plus 150 because we're on top of it. Now, another thing you want to do is set the object variable jump. We're going to scroll down, click camera, scroll down till you get number variable, and click jump. Set this equal to 0. We're setting it equal to 0. And now, when we set equal to 0, it will just make sure that we don't fall through it. Now, as you can see, we already didn't fall through the platform, but this just makes sure we don't fall through it because maybe the game might skip a frame and we could possibly fall through the plane. Now, the next thing we want to do is program the jump itself. We're going to program the jump itself. Now, let's add a new sub-event. Now, this sub-event has to be a sub-event of this sub-event that I'm scrolling over right now. So I'm going to right-click this and add a sub-event. And this sub-event, we're going to want to put if space key is pressed. So I'm going to go to other conditions. I'm going to go into keyboard. And I'm going to go into key press. And I'm going to type space. Now, if space key is pressed, and you can set this to trigger once if you want, In this case, I'm not, so we can hold space because in Minecraft you can hold space to jump. And I'm going to set the jump variable. Now, this is where this jump variable comes in. I'm going to click into camera, scroll down, and change the number variable to jump. And we're not going to set equal to, well, we are going to set equal to 4.3. Now, I'm doing this specific value. I've programmed it before, and I like this jump value. But you can set this to whatever you think fits best. Now, one thing warning is this is not a sophisticated jump formula that we have, a falling and jump formula. This is not too sophisticated. If you want to make a really good one, you might have to actually do some research on physics, a little bit of physics of making realistic jumping with acceleration. Because right now this moves at a constant rate. But if you want to make realistic jumping, it takes a little bit more mathematics and some physics. But it's not impossible. Now I'm going to click preview. And now, as you can see, I'm standing on the plane. And if I press space, I go up and I go down. I go up, go down, go up, go down. And you might be wondering, how did I jump just by setting the thing to 4.3? Now, if you look at this code here, it subtracts a certain value. It subtracts, well, our Z position is always being changed by to whatever jump is. It's always adding jump. So when we press space, it adds 4.3. It adds 4.3 with also with the constant changing of this, but it adds 4.3, so we have a temporarily state where we go up. But that's how it goes up just by us doing this. Now, one more thing, we want to make a collision for the top of the player's head. So if we hit the top of a block, we won't go through it. So I'm going to click into this condition up here. I didn't want to add it there. Let me delete that. Click into this condition right here where it says camera and collision with planes, and we're going to right click and put add a sub event. It's important that you click this first or it won't work right. Now we're going to do something similar, something very similar to what we just did here. So I'm going to actually copy this. I'm going to copy this code and paste it here. And I'm going to delete the space part because this has nothing to do with the jump. And basically we're programming if the top of the player's head touches something. Now, instead of checking if jump is less than 0, we want to check if jump is greater than 0, because this signifies that we're rising and we're not falling. So, for the values here, we want to put camera.z. We can keep the camera.z plus 8, and we can actually keep greater than this too. We can keep this whole first part right here. But for the second part, let's double click into it, and let's put minus 32. Let's put minus 32 for this range. And let's put if it's less than planes group dot z. Now the only reason why I'm putting 32 here because that's the width of our player. That's the width, height, and depth. This value that you put for 32, this is based on the width, height, and depth of the player. Same thing for this 8. You might be wondering why are we using 8? This is because this is 1/4. This is 1/4 of our height, depth, and our width. And basically just set this top value as 1/4. And set the bottom one, it can be the width, height, and depth of your player. And now what we want to do here, if we collide with it, we want to change the Z position of the camera. We want to set it to planes.z. Instead of putting plus 150, I'm going to put minus 8. And the reason why we're putting minus 8 here is because we're basically telling the game, push the player down. Push the player downwards so we don't keep colliding with this. So push the player downwards. And we're going to set jump once again equal to 0. And I can't test this right now because we haven't built anything upwards, but if you test it yourself, you'll see that, okay, you can't jump through blocks. Now, what's the next thing we need to do? What is the next thing we need to do? Now let's get into our upbuilding. Our upbuilding is going to be very interesting because we have to spawn it at a certain Z position, which we already have covered. But you might be wondering, how do we signify that we're in a certain height? How do we tell where to spawn the Z position? How do we do that? And we're going to do this by doing what I call block offsetting. And basically we're going to have a variable that controls the offset of the blocks. And what I'm going to mean by that, basically depending on the height, the Z of our player, is going to set the block offset, which is where we spawn it on the Z, to a certain number. Now let's get right into it. Now the first thing we need to do is double click into camera, go into variables, and add a new variable. And I'm going to name this variable and make sure it's a number variable. I'm going to name this variable block offset y because that's exactly what it is. It's setting the block's offset of y. And we're going to set it its starting value as equal to 0. Now look what we're going to do here. And one more thing, look what we're going to do here. I'm going to add this a little bit later, but I'm going to add a new event and right click and move into a group. And let's call this block offsets. And basically what we're going to do, if our Z position is within a certain range, is going to set block offset to a certain value, and that'll tell the game, okay, I spawn the block at this Z position. And that's why we coded the way we did things in part 1, because it's a very flexible way of programming the blocks. Now, what do we want to do here? Let's start setting our ranges. Now, keep in mind the ranges that I'm about to put, I've tested these before. You can change these ranges if you want, but the ranges I'm using are based on how high we're jumping. And I want you to note that if you're going to change how high you jump, you're going to have to adjust these ranges because these are all based on the Z positions that you can possibly be at based on our jump. So if you're going to change the height of your jump, make sure to change these block offsets as well through testing and through debugging with text that are set to a certain variable. Now, let's start with these ranges. Now I'm going to add a new condition, and I'm going to go into other conditions and go into events and control flow, compare two numbers. We're going to use compare two numbers a lot. Now the first one is, actually we don't have to do compare two numbers. We could do it this way, but there's an easier way to do it. Let's go into camera, and let's scroll until we see the Z elevation. And we're going to put if the Z, I almost said Z order, if the Z, which is the elevation, if it's greater than 240. If it's greater than 240, like once again, these are tested ranges, so don't worry about wrapping your head around them too much. These are just tested Z ranges. If it's greater than 240, and I'm going to put add a condition, other conditions, go to events and control flow, and put and. If it's greater than 240, and if it's less than, I'm going to go to camera, go to Z. If it's less than 340, if it's less than 340, now what we want to do is set block offset equal to 170. Now what are we doing here? Basically our block, now I'm going to go back into our scene. If I click into this stone right here, it's set at 100. It's Z right here is 100. Basically we're saying if we jump up a little bit, if we do a singular jump on the ground, if it's within these certain Z ranges, we want to, when we spawn the block, we want it to spawn at 170. And the reason it's 170 because the height, width, and depth, mainly because of the height and the depth. Since it's 70, we want to spawn it at exactly 70 away from it in terms of its height. In this case, the Z. So that's why we do 170. We're going to set the Z order. We'll set the block offset. So I'm going to add an action here. And I'm going to click into camera, scroll down till I get to my number variable, change the number variable to be equal to 170. And these values are based on, the block offset values are based on the height, width, and depth of your block. Now, I'm going to copy and paste this like 3 times because we're going to be using something similar to this. Copy, paste, copy. Well, I can paste this again, paste this one more time. And for my next value, this actually is going to be a lower value. Now, I'm going to put if it's greater than 148, and you can edit along with me. Make sure to pay attention to these. If it's greater than 148 and less than 240, and you kind of see that they kind of correspond with their maximums and minimums. And I'm going to set where we want to spawn it to be equal to 100. Now the block offset is 100. Basically, we're saying if we're on the ground, we want the Z order to build at to be 100. And then the next thing, if it's greater than 340 and less than 410, we want to set the z as equal to 240 because we're adding 70 again. And last but not least, if it's greater than 410, if it's greater than 410 and less than 480, we want to set block offset to be equal to 310 because once again, we're adding 70. And like I said, we can't test this right now. We have to program the building first. But just know that when we jump and go on certain offsets, this will work. This will work. Now, one thing I forgot to do earlier was with finishing our plane collisions. We did not finish our block collision, what I'm trying to say. Now, if you see me, if I run into this block right here, if I run into this block, I can go through it because I didn't program it. I can jump on top of it. I can jump on top of it just fine because of plane, but I'm still going through it. Now, how do I set this up? Now, you might think I can just use separate objects, but that doesn't work because, like I said, separate objects, it still thinks I'm in a 2D plane. So even when I try to jump over it, it will still collide because it's at the end of the day, it's a 2D engine. So let's add a new event under this, under plane collisions. And I'm going to add a new condition and make sure this is not a sub condition. I'm going to put it right up here. And basically what it's going to do is, well, we have to actually add this first. Plus, go to this plus symbol right here and put for each object. And the object we're going to be using is for each stone. Basically, all stones will be checking this, what we're about to put. All of the stone objects are going to be checking this. Now, what we want to do is check if the Z position of camera, so I'm going to click camera, scroll down to Z, and here I'm going to put if it's less than. If it's less than stone.z, if it's less than stone.z plus 150. And you might be wondering how this works if it's less than stone.50, well, plus 150. Basically, we're saying if it's less than this offset of the stone. Basically, stone plus 150, that signifies the top of the stone. So basically, if our Z position of the camera is less than 150, then we want to separate the objects. But if it's greater than it, which signifies that we're above it, then we don't want to separate the objects. So I'm going to put add an action, put click camera, I'm going to type separate objects, and the object that we don't want to move is stone. Now if I click OK, hit preview, if I let it load, I can no longer just go through blocks. I actually collide with them, but I can also jump over them. And the way it is, I has a little bit of land on the edge a little bit there. I can actually jump over them. Now the collision values are not 100% perfect because these values, like I said, they can get kind of tricky. It depends on the way you move them. I may have to make another part if you want some better block collisions. I did leave out a certain piece of code because I wanted it to be simpler. But if you want that, I can also post it in the description of the video for better collisions for these blocks. 'Cause I know how to do it, I just didn't do it for this specific tutorial. Now, let's get into our final part, which is finally what we all want to do, which is building up. But before we get into building up, we have a slightly more boring part to do. We have to signify when we're building downwards, because what I'm going to show here, I'm going to click preview again. When we're building downwards, basically we want to jump. When we jump, we want to look down and build. We want to look down and build so we can just, keep building up and down. Basically we have to detect the certain ranges of our camera's angle, or of our camera's rotation, not its angle, of its camera's rotation, and that signifies whether we're looking down. So let's see this. So I'm going to go into our double click into our camera, and I'm going to go into variables. I'm going to add a variable, and it's going to be called looking down. It's going to be called looking down. Now I'm going to click looking down is going to be a Boolean variable. It only has two values, true or false, and by default it's going to be false. Now let's scroll all the way down. I'm not going to add a new group of objects or a new group of events for this. I'm just going to go straight off the bat. Now, once again, I've tested these angles, but you really don't have to test them or change them yourself because these are some pretty good angles that signify whether you're looking down or not, but if you want to, you can check. Now, I'm going to go into add condition, and I'm going to compare two strings, and that means we go to other conditions, events, and control flow, not compare two strings, compare two numbers. And the first expression is going to be the camera's rotation, because that's what we're trying to check. So in order to check that, we put camera dot rotation, and it can't just be the regular rotation. You see X and Y. We want to do camera dot rotation Y, put the parentheses, and if it's greater than 49, and you see this is kind of close to 50, if it's greater than 49, and I'm going to add a condition, we're going to put and, events control flow, go click and then last but not least, we're going to put, let me see, compare two numbers once again, and I'm going to put camera dot rotation Y, and then I'm going to put if it's less than 91, because, wait, I forgot you can't put it here. Let me put, instead of the equal here, less than, and then here is 91. Now, if it's within this range, that means we want to set looking down to true. And you can almost visualize the angles in your head. When we go down, when we scroll our mouse down, the camera dot rotation Y goes up. And when we scroll our mouse up, the camera dot rotation Y goes down. That's how it works in Gdevelop. Now what we want to do is set looking down. So we're going to go into our object variable by clicking to camera, scroll down, find the Boolean variable, change looking down to true. Now, how do we set this off? Because if we don't have a way of setting this off, it's always going to stay on and our game is not going to work right. Now, we want to set a new condition. So I'm going to put right click this, add a new event below. And we're going to use OR. We're going to use OR because we want to check if either of these conditions are true. And when you're using OR in Gdevelop, you have to first put OR, and then for all the things that you want to apply that OR to apply to, you put it under OR. So you can't put OR in between. You have to put OR and then things under it. So I'm going to start with OR, and then I'm going to click here. Actually, I'm going to copy this part right here, camera.rotation Y. I'm going to paste it. I'm going to put if camera.rotation Y is greater than 91, if it's greater than 91, or if it's less than, I'm going to copy this. Well, I can just paste it again. Or if it's less than, make sure you put a less than symbol. If it's less than 49, which we already have here, copy this looking down and set it equal to false instead. Now this will now control our ranges. Now if my camera is within these ranges, looking down will be false. Now why does this matter? Let's finally get into our part, which is building, and there's no more holdups. We're actually going to get straight into our upwards building. Now that we have everything set up, it's not going to be too hard. We just need to add a few more things. Now the first thing we want to do is go back into our building code. Now here you see we're allowed to do all of this building free, willy-nilly. Now we have to set a few limits. And the first limit that we want to set is that since none of these are upwards building, well in this case kind of almost downwards building, but since we're building up on none of these, if looking down has to be false in order for this to work, because we don't have this distinction. That means when I try to build down, it will also build up. Well, it will also build to the sides as well. So I'm gonna start with this one. And if looking down is false, I'm gonna put add a sub condition. Well, add a condition right here. Gonna click camera, and then I'm gonna go down to the Boolean variable and go to looking down if it's false, and I'm gonna put it up here. It doesn't actually really matter where you put it. Well, I guess it really doesn't matter where you put it. So we're gonna keep it here. Now, the next thing we want to do is copy this, and we're gonna paste it on all of these. All of these one that we have, paste it at the bottom of the conditions tab for all of these buildings. Place it at the bottom. Make sure you're not going to the sub condition. Okay, now we need to make a new programming for actually building downwards. So the first thing we want to do is, let's see, let's add a new event below. Click into this one right here, add a new event below. And the first condition we want to do here, if the variable of jump is not equal to 0. If it's not equal to 0. Basically, in order for us to build down after jumping, we have to be in the air. So we're checking if it's not equal to 0. So I'm going to add a condition. I'm going to put camera, scroll down till we get to our object variable, number variable, if jump is not equal to, and you could invert the condition with equal, but there's really no point. We have the command for a reason. If it's not equal to 0, and I'm going to click OK, and that's the first condition here. And the next condition is we want to pick the wall. We want to pick the wall that is nearest. That's nearest to what's the word for it? We want to pick the wall that's nearest to the player. The player. So let's go pick the stone. I'm gonna copy this and just paste it from here. And I'm gonna scroll back down. You see our looking down and looking up code right here. Now we want to check if both of these are actually true. And basically we check this by seeing if looking down is true. Because we could technically brute force and put the actual conditions there, but that would take much longer, so let's not do it. So we're going to check if looking down is true. So I'm going to scroll back up, and there's a lot of commands. I'm trying to make sure I don't get mixed up. So I'm going to scroll back up. So we're going to check if looking down, so I'm going to copy looking down where it says right here, copy this, and paste it down here. And instead of checking if it's false, we're going to check if it's true. Well, now we're checking if it's true. And now let's copy this Z position, change it to right here. And we have to create a new far variable, because if you were here from part 1, we use these far variables for our building commands. So I'm going to double click here, and wasn't part of the blocks. Let's go to our stone variables, and let's create one more far and call this far7, and this will be a boolean, and this boolean by default is equal to false. And now we want to not only set the Z position, we're not going to set it to 100 actually, we're going to set it to block to the object variable. So we're going to put camera dot variable, and then we're going to put parentheses, and the name of the variable is block offset Y. And we're going to change this for all the other ones later. We're going to change it for all the other ones later. So I'm just going to copy this and save it for later, because we're going to paste it for the rest of them, because that's why we made block offset in the first place. Now we're going to set the variable. I might as well just copy this. I'll just copy it again later. Set the variable, instead of far6, put far7. Put far7 and set this to true. And then once again, we want to pick. Oh, I forgot. This was supposed to be in a sub condition. So now I gotta paste these in a sub condition. Let's add sub events, and let's pick the stone that's farthest away from the camera once again. Pick the one that's farthest away from the camera, and then instead of putting it up here, we're gonna cut this, and that means we get rid of it and still copy at the same time. We're gonna cut this. Let's cut this once again, and we're gonna paste it down here. And now for our conditions, I'm gonna basically use the same ones that we use up here, because it's the same thing. We're spawning the stone extremely far away first, so I'm gonna right click, copy this, paste. We're gonna paste all of these in here because we can reuse every single last one of these. That's the whole reason why I made it this way, so it could be flexible. So we're gonna copy and paste all of these into the first action. And basically what we're doing is spawning the blocks super far away, and then we're setting the Z order to the block offset. Now we have to go back down to our far section, because this what actually like sets the stone's position to the right place. Now I'm going to copy this one right here. It doesn't really matter which one you copy. I'm going to paste it and repeat for each instance of stone. And instead of putting far6, put far7. That's the new one that we made. And we don't want to change the X position anywhere at all, because we're spawning it on top of another block. So the X and Y position offset is going to be the same. So we're going to keep it here, close this block. Make sure you put far6 for this, not far6, far7 for this. And let's check the code, make sure there's no bugs. Yep, everything seems fine. Now let's finally, before we go test, let's go back up and do what we said we were going to do, which is we set all of these Z positions, all these commands that say change Z position to 100, we're going to put change Z position to block offset Y, because that's actually flexible. So I'm going to copy this, all of this, and go to the value where it says 100, and I'm going to click into it and put Control V to paste very quickly. Just put Control V. So I'm going to go to all these commands and do the same thing. Set this to this, set it to this, and so on and so forth. And we're almost done. Set this, and this is the last one, I believe. Yep, that's it. Now we should be able to jump and build up now. Now I can build to the side like I always can. I jump on top of it, and then I build up. And like I said, the reason why the collision is glitching, I didn't want to add the code to it because I thought it was going to work fine without it. It was at first, but I'm gonna have to add this. I'm gonna copy and paste the code that you need to make this work in the description. I'm gonna like have a link to it and maybe like a picture or something. But I'm gonna just paste this in this way so these upwards collisions can work. But once you put that code, you can just copy and paste it. Once you get that code, everything will work fine. And I know you might be wondering, how do I build upwards? It's the same thing. I just didn't want to stretch out the tutorial for no reason. But it's the same thing. All you have to do is use the same, not the same ranges, different ranges for the camera rotation, upwards instead of downwards, and copy the code that you use for the for this for the upwards. You're going to get some different block offsets ranges, but that's all you have to do. You basically use different block offset ranges, use different rotations, and it's the same as up, basically just in reverse. But I hope you all enjoyed the tutorial. That's how you do jumping, collisions, and upwards building in Minecraft. Remember to check the description. I'm going to have the link to a picture that shows all the code that you need to get the collisions on top of the blocks working correctly. But I hope you enjoyed the video once again. If you enjoy content like this, please like, subscribe, comment, and hit the notification bell so you never miss on any of my new videos. And once again, I hope you enjoy it. Thanks for watching, and I'll see you in the next tutorial. See ya.